What's up, guys? Welcome to another video, and we're going to start a series, and this is going to be a kick butt series, okay? This is going to be a series on building a home server rack and lab, okay? And we're going to go across multiple devices, and we're going to start pretty simple. We're going to start with the networking, right? Because that's, you know, either you start with the power or you start with the networking, and then you build up. And today we're going to look at a patch panel. And you're like, wow, that's kind of not so exciting, right? And you're right, it's not. But what a patch panel brings to your setup, and it isn't required? No, it's absolutely not required. It's more of a convenience. It's more of organization, like, you know, like clean cable setup, you know, and stuff like that. So is it absolutely something you got to have to do a home server lab? No. Now, shout out to TrendNet. They did provide this to the show to review. They did not charge me for this, but they have not reviewed this content. So this is an unbiased review of their TrendNet, and this is the TC-P24C6AS. Okay? I'll put that in the show notes. You don't gotta worry about it. You don't want to rewind this and listen to the model or anything like this, right? So this is a shielded patch panel. And let's just go over a lot of the details, right? So it's 24 port, it is Cat 6A, and again it is a 1U patch panel. So this is a server unit is a U, so this takes up one server rack unit. Okay, and if you need to look some of that stuff up, feel free. If you need to look up what shielded is and all that kind of stuff, or 6A, you know, feel free. That's what this video, you know, you kind of pause and you learn when you're trying to learn this kind of stuff, and if you need to figure that out, you can. And I'll try to go into some detail, but I don't want to make this a super long video, right? Okay, so Cat 6A, that supports IEEE 802.3AN, okay? That means this patch panel will support the 10 gig base T, all right? And that means that it's TIA augmented category 6. Yeah, it's a lot of weird stuff, right? Okay, we'll go on. So, shielded, what does that mean if it's shielded? Well, so what that does is it helps prevent EMI, which is the electrical magnetic, you know, interference that, you know, if you're a ghost hunter, you're like pinned in on, right? So what that means is, like, if you've got a lot of power that's running close by and stuff like that, that shields it from that. So it basically makes it a cleaner signal through your network that if you've got some beefy stuff, a lot of stuff powered up, Wi-Fi, all that kind of stuff can create interference on a network. So shielding it means that it blocks out the EMI. Okay? So it's a flat patch panel design versus angled. Those are usually a little bit better to deal with versus the angled. They're copper gigabit, basically copper gig, and it'll go up to 10 gig as mentioned, right? So it'll support those 10 gig switches. You got to have the switch to support 10 gig. This isn't going to give you 10 gig alone. It will support it. It'll also support power over Ethernet. So PoE, if you've heard of that, this does support PoE. Also, this will support Cat 5e, Cat 6, and 6A, so it is backwards compatible with all of that. It does not support Cat 7, as far as I know. I don't have Cat 7, but I don't think it supports it. So what is the difference between 5e, 6, and 6A? Right? You're like, what is that? So the cable here, the network cable that you can see right here. So 5e is TIA EIA 568. That's like you know, it's certifications, or it's can't think of the word, right? Cat 6 meets or exceeds that, right? So that means you're going to be able to do 1 gig throughput, not a problem. I think 5e, you know, you get a little bit more limited in what you can do. You can't do 10 gig, obviously, on 5e. So you want to be able to do 6A, which is pretty much the standard anymore. So if you're looking to do any networking, stay away from 5e and 6. Go with 6A or higher if you want to, right? So 6A, what it basically does is it supports all performance of the older ones, right? And it does the IEEE 802.3AN, which is 10 gig over 100 meters, right? So you get some distance there that you can now do 10 gig over. And it is best for PoE. It supports power over Ethernet due to the reduced resistance, the lower temperature, and the minimum power waste that it does. So if you're doing PoE, that's the best choice right now that you can do. So these labels are color coded in here. These have what they call keystones in this one. Some of them are blank. This actually has the keystones built in. Some people don't like the keystones, some people do. It just depends on your preference and stuff like that. We'll go into what these keystones do and how you work them, but they are labeled for the T56A and the T568B. And again, steer towards the 568B because that is where all your future capabilities are at, right? 568A is backwards compatible, like for telephone wiring. That's how old it is, right? You ever seen those old phone jacks and stuff? Then that's telephone wires, and that's usually like, you know, old stuff. So let's try to stay more to the beat. Again, best for PoE, and you know, it's 8-pin modular connector plugs basically, right? This is what this is. So it is 110D or IDC type terminal blocks. So that basically, you know, means that they're insulation displaced connectors, right? Also does Crone 110 termination. So that means you need a punch down tool. And that's what this is. This is our punch down tool. So this will actually put this, and we'll do a quick little demonstration of how you punch down this into the keystones. And the weight of this is 3.5 pounds, and I would put it in the top of the rack, usually, right? Not maybe like right at the very top. You might have your switch or a firewall or something at the top of the rack, but this goes somewhere near the top. And then, again, why do you need it? It's neat, tidy cable management, it's convenient. You don't have to get in the back usually to do a lot of work. You can work from the front by changing the ports, right? Pretty easy. And that's really the gist of it. So it's just really a middleman to your switch. That's the simple way to label this. This has all of your connectors in here in the front. So basically what you're going to be doing is you're going to be wiring up these keystones with your network cabling, and then you're going to move these cables behind everything into the equipment in your rack. And the other side of this is going to have a male RJ45 connector. Okay, you're going to strip the wires, and you're going to use these 8-pin connectors. And I've already got one going. So as you can see right here, a little spoiler, I have started putting the colors in the right labels. That's why these are labeled already. They've got little labels in here. If you can see, if I can get in here, they've got the color coordinations for the 56A and B. So you're going to want to use the B more than likely. This also has a ground, just so if you see this, you're going to ground this to your rack. And it also has a little bit of grounding built into it for cable management. These little holes right here have the screw, and then these little cable managers, right? Let's see if we can get one. I've got one installed over here, but so basically you're just going to take this, you're going to screw it into one of these holes, and your cable is going to go under this, right? And that's going to ground it, and it's also going to make it that it doesn't move. It's going to be pretty tight. So you have all of those you can do that with. Now, what we're going to do, if I can zoom in just a little bit, hopefully. All right, we're going to zoom in so you can get a good look, and we're going to punch this baby down. So we're going to remove this. Now it's very careful here because this has a cutting into it. So when you punch this down, if you have it the wrong way, you're going to sever your cable and it's not going to work, right? So basically, you're going to come in here and you're going to punch these down. Now, let me see if I got this in here. So I'm going to put this. Now the sharp end's going to go on the outside, right? Because we're not going to want to cut our cable, except on the outside. We don't want this hanging out spaghetti wise. Let's just do the green first, right? So I'm going to push that down in there, and then I'm simply going to push down, maybe. Behind the camera is not as easy. And what that does is it punches that green wire down into the connector, and it should have severed this green wire. Yeah, see, so the green wire comes right out. Hopefully you can see this. There. So we cut off the excess, and we're good. So we'll do that with the green-white. All right, so we're going to put this in here. Make sure we got the cutting edge. Usually I don't do this behind a camera. Usually I do this up close and personal. So what we're going to do is push that down. Boom. And we cut that green wire, and we now have put that in here. And I think this one's already done. So I think it just needs to be pulled off. Yep. And then we just do the other side, right? So we put these cables that we've spliced in here, and we put them in the appropriate side, and we cut them. And I've already done the brown. Looks like I have blue, and if I follow this, blue, white, and blue. So I'm going to have to move the blue, white here. Alright, this is kind of tedious work, so if this is something that you don't like to do, then maybe this kind of patch panel is not for you. If you don't like dealing with these small little copper wires and this cable, then it might not be the best. Again, we're going to push this to where our cutter is on the outside, not on the inside, because we don't want to splice our cable on the wrong side. And we've got that one. And now we do the blue-white. Again, cutter on the outside, punch down. And we have just successfully cabled that bad boy. Now, when I say about cable management, this is where we would take this, we'd push this down, and then we would just screw this in. And we're basically managing our cables and grounding them like this. That makes it just tight. Like that. Bingo. And there we have just completed a keystone, and we have now made this port 1, hot to this cable, right? So then what you would do is you would take the end of this cable, and I've already got it spliced, and you would put this into a male RJ45. You can do it to a push through or a pass through, whatever they call them, and then crimp it. And you would have a male in, and you would plug this into something that would be in your server rack, right? So then what you do is you put this on the rack, you would put a patch cable from this port to the switch. So the switch is going to have your ports on the front, your patch cable is here, and this is what does the network connectivity, right? You don't take this and run it to the back of the switch, or run it from the front to the, however, the back of the rack to the front of the switch. It looks terrible. This gives you very good organization. And we'll revisit this in the future. I got to get this whole thing, well, I'm not going to use all of these ports, right? I'm not going to use all 24 of these ports, but this will give me the ability to load all up these keystones and then run these cables to my servers, my PDUs for management. Some of them have IP addresses and all that fun stuff. Again, this is the cut side. Cut, cut, cut. So our punch down tool. That, my friends, is the TrendNet 24.6AS Shielded 1U patch panel. And we will do a follow-up video once I get this all loaded and punched down and cabled. We're going to go to the front of the server rack, and I'm going to show you the patch cables. They're very short. You don't want long cables, right? It's literally going to reach, I think they're like maybe a foot long cables. This is going to be right under or right above the switch, and we're simply going to, just like an old operator would at a telephone company. You ever seen those old phone operators where they would patch somebody in on the panel that they're running? Same concept. You're just patching the network in. This is the middleman, right? So that's a great example of what these actually do and look like. And this is the first in a series of setting up a home lab. We already have the rack, we already have the switch, we have all the equipment, and we're going to start doing a separate series, not just focused on this. We'll still have product reviews and stuff like that, but I wanted to start the new year with some technical stuff. And we got some cool technical stuff. The servers that we're going to have in this, you're going to like. We're also going to do Raspberry Pis. We're going to have some PoEs on some Raspberry Pis. They're going to run stuff in the lab. Like I said, we have a PDU. We've got a KVM console. We just got a whole bunch of stuff we're going to focus on. And then we're going to dive into what's running in the lab. We're going to run virtualization. We're going to run containers. So we're going to do some kind of little Docker fun. And we're going to run some home automation. We're going to run a bunch of cool things in this lab. This is going to be a low voltage, low heat disbursement, low noise, low cost lab. And when I say cost, I mean operational. Purchasing some of the equipment, that's going to be your hurdle. And you don't absolutely need what I'm going to have in my lab. But like Raspberry Pis obviously aren't that pricey, right? And you can do a lot on a Raspberry Pi. We're also going to introduce some other little 1U boards. We're going to have some Zima boards in the lab. So a lot of the stuff is low voltage. Some of it's like one single board processors that are going to be super powerful. But we're going to have some servers in here too. But I think you're going to like it. So stay tuned for this series. Watch for it. I'll try to notate it so it's not mixed in with all the other tech product reviews and stuff like that, because this is going to get some technical stuff, right? So if you're up to this, put a comment on there what you'd like to see maybe, and if you're interested in this, and if you like the video, subscribe to the channel. That helps out, and prepare for the ride, because we're going to be diving into some pretty cool, sometimes very technical stuff. And if you want to learn it, follow along. I'll try to explain most of it, but some of it you're going to have to look up on your own, because these videos would get way too long. Again, like, share, and as always, thanks for watching, guys, and have a good one. Alright guys, welcome back. So we have wired up most of this TrendNet patch panel. I think about 16 ports. If I can lift the lid here on this bad boy, you can see what we've got under the hood. Eight wires, cables, whatever. Basically, you know, they've been punched down into this, much like the old telephone systems, right? And we've got all of our connectivity ground. And again, this is a shielded patch panel, so definitely one of those things where it's going to eliminate electricity. I am going to do some PoE on this, and this is the test that we're going to do. This port here is into a PoE, we'll call it like a little hub. It's not really a switch, but so we've got a little PoE provided hub back here. So let's go ahead, and I'll put the lid back on here, hopefully. Behind the camera, this isn't always the easiest task, but hopefully we can get it in there. If not, I'll leave it off, and you can just kind of see how this works. Alright, behind the camera, not such a good idea. Okay, let's get, now I can't get out. There we go. Alright, we'll leave the lid off. Okay, so first thing is, when you've got these wired in, you really want to test. So these back sides are males. They're going to go into the back of equipment in a server rack, correct? And then the front gives you the ability again to just wire. And what we kind of use, you can see I'm using a real long one here, but that's not a patch panel cable. This would be a patch panel cable. Okay, they're very short. So I'm just going to patch this in, much like I mentioned earlier in the video, like an old telephone operator, right? I'm going to say, okay, this is going to go in this port, and it's going to connect to this port on the switch, and we've now made connectivity through a patch. We're basically the main in the middle, right? So anyway, once you've created your cables, the thing you want to do is, this is a cable tester. So we've got the RJ45 plugged in. The other one's an RJ11, so we're going to test the RJ45. Plug it in, you can see it's got a little bit of blips because this one does have PoE. And basically what I'm going to do is I'm going to turn this on, and it's going to go through each cable. Now there's 8 of them, so here we go. And what we're getting is a clean bill of health on every cable in that port. Boom. Alright, so I did want to provide that. Now, quick little video, and then we're going to rack this bad boy up, and we're going to kind of hook it up. So again, this has PoE. So what I've done, and this is a video coming separate, is this is a Raspberry Pi 4. And so what I installed is what they call a hat on top of a Raspberry Pi, and basically this hat provides PoE to a Pi. So one thing that you've always got to do is like provide power to a Raspberry Pi through like one of these ports on the side here. You know, could be Type C, just depending on what kind of Pi. This is actually, I think, a barrel plug. So watch this amazingness now. We're going to plug in this RJ45 jack to this Raspberry Pi, put it on the network, and look at this. It's providing power to our Raspberry Pi. No need to plug it in anywhere else. We're getting the power we need directly through the network, directly through this patch panel. So if you're ever wondering, like, well, does this patch panel support power over Ethernet? Well, I just proved it does. By going through this blue wire into this power over Ethernet switch, or hub, we have now provided power over Ethernet through this patch panel. So it does work flawlessly, and it's shielded, so it's very, very good to use with power over Ethernet. And we'll have a separate video on the Pi thing, right? We're gonna ramp up Raspberry Pi stuff too. And we're gonna do some technical videos along with our normal gear reviews and things. So this is definitely one of those. This is another one, an RJ45 tester. So I can plug this in, and you can see. I think this one actually you have to complete the circuit. So this is just saying, yeah, it's got connectivity 1, 2, and then this is the remote one. So this is just kind of testing in the middle kind of setup. So let's go ahead and rack this up, and I'll give you a good demonstration of what this is going to look like once it's in my rack, and we'll wire up a few of the components in our build and get them on the network. We'll be right back. Alright guys, so we have racked up the patch panel. Now you can see my main switch is on the top. It's a Zexel. Zexel? I don't know. Might be butchering the name a little bit, but they did sponsor this series, so their switch here and their firewall we'll be looking at. But, so I wanted to demonstrate. The back side is wired into the switch, alright, from the patch panel. And I've only wired the first 3 ports. So they all go into one server. There's 3 network adapters or plugs in the server. So I've put all 3 of them in there. One's an IPMI, which is out-of-band management, which is what we'll use to set up that server. And then the other 2 are the onboard NICs. And you can see 2 of these lights over here are lit up, port 1 and port 2. So just to give you an example, if I am to come in here and plug this one in, we should, there, that one just came online. And now this one server is patched in to the switch in the front. So now you don't have to get behind the server rack, dig through the cables, which, by the way, if we go down here and you want to see what this is still in progress, don't judge. But would you rather be down here working with cables, or would you rather be up here just like moving cables around like that? Remember the old operator at the old telephone punching operations, right? Just boom, 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 boom. We're patching these in. These ports are hot. These ports are hot. Now, if I plug in all of these here that are just dangling in the back, they become hot, but I have to patch it into the switch. So, as you can see, it's pretty cool. We're going to bring the firewall online. We're going to bring the switch online. We're going to configure it because this isn't configured. In fact, if I was to boot up this server, I'm going to move the camera. It should start to look for a DHCP. So let's go ahead and just lift this up. And maybe I can get this screen in here. let's just power up the server and see if it's looking for a DHCP, because we haven't configured that yet on the switch. So the server, though, being wired, we should see it somewhere as it boots up. Start looking for an IP address, because it's like, oh, hey, I am on a network. So am I going to be handed a DHCP IP, which means you're just, it's not static, it's a dynamic thing, it could change. It tries to keep it the same, but if it goes off the network for a while, it forgets about them, and we'll give them a new IP address. So basically it's just a pool of IPs that which is on the network that it gets handed out. So let's see if this actually starts looking for a IP address once it boots up. Got a couple splash screens here, trying to get through the boot sequences here. Grab some popcorn, a soda, a snack, and there we go. It's in its DHCP mode right now. And I'll zoom in here so you guys can see. Now it's not going to get one because I haven't configured the switch yet. So there's no DHCP being handed out. There's no DHCP server on this network. There's not even a WAN. It's not connected to the internet. So right now, this is a very isolated environment as we set it up, and that's what you want, right? You don't want this out on the wild while you're sitting here trying to harden it and stuff. So it's completely isolated, internal only, and we're good to go. So there you go. Didn't get an IP address. So anyway, guys, more to come on this series. This wraps up the patch panel. Hopefully I covered all your questions on it. I want to thank TrendNet again for sponsoring the patch panel on this server build series. Again, our finish line is a home lab that's fully functional. And then we're going to run with that and have a lot of fun, right? So that is the battle plan as we move forward. We've got a pretty good setup here, and it's only going to get better as we continue to build it up, add to it, and we got Wi-Fi coming. If you see this up, you probably can't see it up here, but we've got this little white thing is a Wi-Fi. There we go. That is Wi-Fi 6. There we go. So that's a Wi-Fi. Again, Zaxel gave that to the show, so we'll be doing that as well. So just a lot of goodness coming your way that's tech. Like the video, give it a thumbs up, comment, feel free to share, subscribe, and as always, guys, thanks for watching and have a good one.